x, then we multiply by x over 2, right? Then we plus by m as a function of x. The whole thing is equal to 0. So from here, we have m as a function of x is equal to minus 25 times 10 to the power 3 x squared. Okay. So that is our equation. So equation 1, equation 2. Okay. So at the same time, you put onto your table b as a function of x. This is equal to minus 25 times 10 to the power 3 x squared. Minus 50. Sorry, looking at the wrong thing. And then we have moment x is equal to minus 25 times 10 to the power 3 x squared. Okay. So that is our one set of equation done. Okay. So the next one we are going to find at point B. We'll have space over here. I don't have space. I'm going to go over to the next page. But before I go to the next page, I'm going to bring the whole table with me. Okay, and I'm also going to copy this diagram. This diagram is so important. Okay. So next we are going to find where at point B, right? At point B, where x is equal to 0.8. So again, very quickly, sketch your free body diagram. Okay. So this is where the geometric datum is again, right? At point B, this is 0.8. Then you have over here 50 times 10 to the power 3 multiplied by 0.8. The distance from here to here is 0.4. We're going to assume V at point B is coming down. At moment at point B is going direction. But at point B, something happened. Okay. You have a force, right, going up here. Right. You have a force going up there, which is equal. That's a reaction. Okay. So the reaction is what? At point B, we have a reaction of 120. Okay, 120 times 10 to the power 3. Okay. We have a reaction at the point. And again, we do static analysis. Summation of moment, summation of moment, Eugene, seriously. Positive is going up. Summation of forces of y is equal to 0. Okay. So this will be equal to minus 50 times by 10 to the power 3, 0.8, plus by 120 times 10 to the power 3, minus by v at point B. The whole thing is equal to 0. Okay. So v at point B, the shear force at point B, 3 power 3 times 0.8 is equal to positive 80 times 10 to the power 3 meters. Then we do the same. Summation of moment in the z direction at point B is equal to 0. Again, I highlight that we are taking the moment at the red dot that I'm drawing now. Okay. So this will be equal to 50. So the 50 times 10 to the power 3.8 is rotating in an anti-clockwise direction. So 50 times 10 to the power 3 multiplied by 0.8 is in a positive direction. The 120 is not going to cause any moment at all. So plus by moment at point B is equal to 0. So moment at point B is equal to 50 power 3 times by 0.8. is equal 50. Oh, sorry, I forget the distance. Hey. So 50 power of 3 times 1.8 times 1.4 is equal to 16 times 10 to the power of 3 Newton meter. Okay. As I said, at point B, there are constants. Okay, so this is 80 times 10 to the power of 3. This will be equal to minus. Okay, over here, there's a minus sign over here, minus 16 times 10 to the power of 3. Okay. Then we go from B to C. Okay. So if we were to do from B to C now, hold on, let me write B to C. Again, limits is 0.8 x, and we are going to go up to 3.2. Okay. So B to C. So we know that we have over here again geometric datum left hand side. This is x, v as a function of x, m as a function of x. So we know over here is 50 times 10 to the power 3 x. Distance from here to here is x over 2. We are aware that over here, this is our point A. We have our point B somewhere around here. At point B, we have a force going up at, can't remember now, 120? B, yep, 120. 120 times 10 to the power 3. The next important thing is the distance from here to here. Okay, it's x minus by 0.8. Okay, so you have to get all your distance right, then the analysis get easy. Okay, so positive is going up. Summation of forces in the y is equal to 0. So this will be equal to 50. Okay, then we plus 120 times 10 to the power 3. Then we minus v as a function of x is equal to 0. So v as a function of x is equal to minus 50 times 10 to the power 3 plus by 120 times 10 to the power 3. Okay, so this is our equation number 4. Then we have our moments at point x. Okay, as I say, x is our variable. We're taking moment at the red dot. So this will be equal to 50 times 10 to the power 3. Right, you have x multiplied by x over 2 is going in a anti-clockwise direction, so it's positive. Then we have the next one is minus 120 times 10 to the power 3, x minus 0.8. Then plus by m as a function of x. The whole thing will be equal to 0. So you bring everything over. So m as a function of x is equal to positive will be negative 25 times 10 to the power 3 x squared plus by 120 times 10 to the power 3 x minus 0.8. Okay. So over here, you get minus 25 times 10 to the power 3 x squared plus by 120 times 10 to the power 3 x minus by 120 power 3 times by 0.8 is equal to 96 times 10 to the power 3, equation number 4. So you have equation number, you have minus v as a function of x is equal to what, minus 50 times 10 to the power 3. Oh, I missed the x down here. Minus 50 times 10 to the power 3 x. Then we have plus by 120 times 10 to the power 3. And then our moment x is minus 25 times 10 to the power 3 x squared plus by 120 times 10 to the power 3 x minus by 96 times 10 to the power 3. Okay. So just to quickly recall, if you were to integrate your shear force, you get your what? Bending moment equation. But you need to know the boundary condition. We did not find the boundary condition at each individual point. So I think this is quicker. Then we need to find at point C. So at point C is where x is equal to 3.2 meters. Okay. So again, at point C is pretty interesting because at point C there's nothing at point C but the end of the what? Of the shears of the distributed load. So this is our point A. Our point B, we have 120 times 10 to the power 3. And this is where our point C is. So V at point C, moment at point C. We know that we have a load that's 50 times 10 to the power 3. Multiplied by 3.2, distance from here to here is 1.6. And then we know distance from here to here is 3.2 minus by 0.8. And this is equal to what? 3.2 minus 0.8 is 2.4. Okay. So again, summation of forces in the y is equal to 0. This will be equal to 50 times minus 50, sorry. Minus 50 times 10 to the power 3 multiplied by 3.2 plus by 120 times 10 to the power 3 minus V at point C is equal to 0. So our V at point C is equal to minus 50 power 3 times by 3.2 plus by 120 power 3 is equal to minus 40. Okay, so it's equal to, I think, did I do something wrong? 120, 50 power 3 times by 3.2, 50 power 3 times by 3.2. Minus this plus 120 power 3 is equal to 40. Yep, 40 is correct. So we have 40. I want to check. Minus 40, sorry. Yeah, it's minus, wait. All right, this is just summation of forces, UTT sort. Yeah, it's minus 40. Newton. And then we take our moment. Now, what you realize is at point C, you can also use equation number what? Number 3. Okay. Over here, the point B, you cannot use equation number 1. It's because you are introducing the 120 over here, which is not seen in equation number 1. Can you see that? Right, equation number 1, don't take the 120 into consideration. So you have to be careful when you can use the equation before. Okay. So again, we're going to take moment. I know all of you are really bored. I can sense it. Okay. Later on, we're going to change direction. Summation of moment Z at point C is equal to 0. So this will be equal to 50 times 10 to the power 3 multiplied by 3.2 multiplied by 1.6. It's going to be positive because it's anti-clockwise. Then minus by 120 times 10 to the power 3 multiplied by 2.4. Then plus by moment about point C is equal to 0. Okay. So from here, moment at point C is equal to 50 power 3 times by 3.2 times by 1.6 minus by 120 power 3 times by 2.4 is equal to 32 times 10 to the power 3. Okay. So we have, I go back to our table. we have minus 40 times 10 to the power 3, and then 32 times 10 to the power 3. Okay. We have one more set of equation to do. Okay, at point D, we know that both of them are 0, so we put in 0 first. Okay. Now, I'm going to do from right to left, from C to D. Okay, so I just want to show you how does it work. It's not that difficult at all. You just need to flip your directions. Okay, so I'm going to copy that. Oh, I still have space. What am I doing? Okay, so we are going to, so I'm going to copy this diagram over here. So we are going to do from C to D. So what I did from, we're going to do from right to left because there's only one force to consider. Okay, the less components you have, the less mistake you make. Geometric datum is still the same position. Like what I mentioned before, this is X. Okay. So we know that this is your point D, and your point D has a force going up by, I can't remember now. I think is, wait, what is it? 40. Okay. So 40 times 10 to the power 3. The distance from here to here now is equal. So this distance over here is equal. So the entire length is 4. So 4 minus by X. Okay. It's not X minus by 4. Okay. It's 4 minus by X. Then you get a positive number. So this is your V as a function of X, moment as a function of X. It's that straightforward. That's it. Okay. So plus positive is going up. Summation of forces in the y direction is equal to 0. So from here, we have 40 times 10 to the power 3 plus by V as a function of X is equal to 0. V